In this lesson, we're going to be looking at equations of lines that are not written in slope-intercept form, and we're going to be practicing the work that we can do to change them so that they are in slope-intercept form. So if you remember, slope-intercept form is y equals mx plus b. We have a number for m, and we have a number for b. The m represents the slope of the line, and the b value represents the y-intercept. So if you take a look over here at number 1, this equation is not in slope-intercept form. And if it's not in slope-intercept form, then the numbers that we see, the 2 and the 4, do not represent slope and y-intercept. They only represent those values if it's written in this form. And so what that means is we need to rearrange it. So we need to move things around so that we can get the y alone. And what we're going to do is we're going to use the properties that we discussed with solving equations. Because essentially what we're doing is we want to make the y alone. So we're really solving this equation for y. We're isolating the y. And in this case, what we need to cancel out is the 2x. 2x is being added to the y. And so to cancel out a value that's being added, we have to add the opposite. So we're going to do negative 2x on both sides. These cancel out. 2x and negative 2x equals 0, so they cancel out. And now we have the y all by itself. And so we're getting closer to having it in this form. What you have to recognize is we have a 4, a constant, and we have a negative 2x, a variable term. These are not like terms, and so you cannot add them together. 4 and negative 2x cannot be combined. And so what we're going to do is we're going to need to write both of them over here on the right-hand side. We ultimately want the equation to look like this, so it makes more sense to write the x term, negative 2x plus 4. It makes more sense to write the x term first, because that right away turns our equation into y equals mx plus b. So here is our new equation. It means the same thing as this one, but we rearranged it. We moved things around so that it looks like slope-intercept form. And so now we know the slope of this line, m, is negative 2, and the b is 4. Until we change it around, until we rearrange it, we don't know the slope of the line and we don't know the y-intercept. But if we can isolate the y, then we have those two values and we would be able to graph it. Okay, so let's practice another one. Here again, we have an equation of a line, but it's not in slope-intercept form, so we have to ask ourselves, here's the y. What do I need to cancel out if I want to make the y all by itself? The value we need to cancel out is the 7. And it's 7 plus y. So the 7 is being added to the y. We add the opposite, negative 7. Negative 7. Cancel out. So we're getting closer. We have the y alone because the 7's are gone. And on the right, 4x and negative 7x. Again, they are not like terms, so we cannot add them together. We're going to put the 4x first, and then the negative 7, because again, we want it to be in this form, y equals mx plus b, so it makes more sense to put the x term first. So now we have an equation in slope-intercept form. The slope of this line is 4, and the y-intercept of this line is negative 7. And from here, now we could draw the graph, we could interpret these values as we've done before. So in the previous examples, there was only one thing that we needed to cancel out in order to make the y alone. If we take a look at this equation, it's not the same situation. Sometimes we need to eliminate more than only one thing in order to make the y alone, in order to isolate that y. So if we draw the line, and we know my goal is to make it look like y equals mx plus b, so I know when I'm done, this is going to be my equation. So then we ask ourselves, okay, if I need to make the y alone, and I look over here on the left, what do I need to cancel out? I'm going to cancel out the 4x, and I'm going to have to cancel out that 6. We're going to cancel out the 4x first, because if you recall, when we solve equations, if we have a two-step equation, we always add the opposite first, and we've discussed y in the past, so we're going to follow those same principles. So we add the opposite, and we add the opposite over here. These cancel out. I bring down the 6y, so I'm getting closer. Now I only have to worry about canceling out the 6, which we'll do in a second. Here I have 12 and negative 4x. Again, just like we discussed on the previous page, these are not like terms. I'm trying to write my equation in slope-intercept form, so I'm going to put the negative 4x first, and then plus 12. So I'm getting closer, but I still have to cancel out that 6 if I want to completely isolate that y. So to cancel out the 6, because the 6 is being multiplied with the y, I have to divide by 6. Now, this is unique. We have not discussed this before. Anything that we do on one side of the equation, we have to do the same thing on the other side. But what you'll notice is we have two terms over here. So we need to divide. We did divided by 6 here. We're going to need to divide by 6 here and divide by 6 here. So if you have two terms on the right, you need to divide both of them by 6. Okay, so these cancel out. We have the y alone. Negative 4 over 6. That fraction, I'm going to copy down here, and we'll talk about reducing that in a second. So we have negative 4 over 6x. That will be our slope, but that fraction can be simplified. The next thing is the 12 divided by 6. So we do each little part separately. 12 divided by 6 gives us 2. Now the final step here to get to our answer is we have to look at this fraction. This fraction, if we could divide and get an integer, then we do that. But in this case, if we divide, we get a decimal value, and we know that for slope, we never want a decimal. What we can do to this fraction is we can simplify it. Negative 4 over 6 is equal to negative 2/3. So we have y equals negative 2/3 x plus 2. Okay, and so that is our equation in slope-intercept form. Again, it is equivalent to this equation that we started with. Okay, but I've rearranged it, so now I have an equation in slope-intercept form, and now I know the slope of my line is negative 2/3, and the b value is 2. And so from that information, as we have practiced, I can graph the line. Here's my y-intercept, positive 2, and my slope is negative 2 over 3. So I have to go down 2, 3 to the right, down 2, 3 to the right, and I don't have any more space in that direction, but I can reverse the values and go up 2, 3 to the left, up 2, 3 to the left, 3 to the left. And again, I run out of space on that side. Let me erase that one. Okay, and so now I can draw my line. And we always remember to put arrows on both ends. Okay, so one more example here, and then I'll give you a chance to practice some on your own. So we have negative 5x plus 2y equals negative 2. So again, we draw the line, and our goal here is to isolate the y. We want to get the y alone. And so to do that, I'm going to cancel out the negative 5x, and I'm going to cancel out the 2. So again, first thing we do in a two-step equation is we add the opposite. So those cancel out. I copy down the 2y, and I have negative 2 and a positive 5x. Those are not like terms, so I cannot add them together. I'm going to write the 5x first, and then I can write minus 2, or I could write plus negative 2, either way. Now I need to cancel out this 2. It's 2 times the y, so to cancel it out, I need to do divided by 2. And again, remember, you have two different terms over here on the right-hand side, so we're going to do divided by 2 to both of them. So divided by 2 here, and divided by 2 here. These cancel out, so I have my y alone. And if I take a look at my slope value, 5 over 2. If we divide, we get a decimal. We know we never want a decimal for slope. And if I look at the 5 and the 2, they do not have any common factors. So that slope value cannot be simplified. So I have 5 over 2x. And now I take a look here. 2 divided by 2 is 1. So that value is 1. This was a -2, so I have to make sure that I keep my sign accurate. So my slope is 5 over 2, and my b value is -1. And so from here, I can draw my line. So b is -1, and my slope is +5 over 2, so I'm going to go up 5 and 2 to the right. 1, 2, 3, 4, 5, 1, 2. And then I can reverse it because I don't have enough space to continue going up in this direction, so I'm going to reverse it and go down 5 and 2 to the left. 1, 2, 3, 4, 5, 1, 2. Okay, and so now I have my 3 points, and I can draw my line. And again, always, we remember the arrows. Okay, so the graphing component of these exercises is not new. It's exactly what we had been practicing. What's new is that we are going to be seeing equations that are not in the form that we need. We want the equation to say y equals a number x plus another number, because we know if it's in that form, this number tells us the slope of the line, this number tells us the y-intercept, and then we are able to actually draw it, and we're able to interpret a lot of different features of the graph. So what we're practicing in this lesson is if an equation is given to you and the y is not alone, you need to follow the steps that we know, follow the properties we've learned about solving equations to help you isolate the y. Once the y is alone, we have mx plus b, in this case minus, because the b is negative. And so then we have the slope of the line and we have the b, and we can draw it as we have done before.